Bright Tuty. Every student matters.
Now let us see if we are just calculating or converting it with the third equation. We are now trying to derive the third equation of motion. Let us see how we are going to do it. When we are talking about third equation of motion, same graph is going to be used. Let there be a body and starting from some initial velocity, taking this point A to B, it moves uniformly, uniform accelerated motion. Then we will just draw the perpendiculars to get the basic and in depth idea how to draw it. Just please refer to the first equation of motion. There I have discussed this particular graph in very much detail. You will be able to relate it better there. If you are not able to relate, because this is a topic in continuation, right. So, I am assuming that you have seen that first topic also. So, this is the graph. This OA is represented by small u, this BC or CB is represented by V, and this AD or OC is represented by T. This is a velocity time graph. So, velocity on the y axis in meter per second, time in second. Now, the third equation of motion says V square is equal to u square plus 2as, right. We will be calculating and deriving this equation, and we will start up once again with the same thing that we have started our second equation, that is to calculate distance, right. Now, the distance will be calculated with the formula area under the line, area under the line AB. This is the line AB that we are talking about, the uniform accelerated motion of this particular object. Area under the line, we have already seen in second equation that it may be equal to area of triangle plus area of rectangle, or simply the area of trapezium. It is one or the same thing, right. In the second equation, we have bifurcated and divided it by adding triangle and rectangle, and I have said that it is one or the same thing there also and here also. And to prove it, let us see. Let us take now the area of trapezium. So, for calculating distance, I will say distance is area of trapezium. Which trapezium we are talking about? Please relate it in the graph. OABC. This is the trapezium I am talking about, OABC. Now, area of trapezium, I know that it is half into sum of parallel sides. Parallel I have just represented like this, I hope you won't mind it, multiply by height, right. So, in this trapezium, if I relate, the parallel lines are this AO and BC. So, sum of parallel lines will be OA or AO, one or the same thing, plus BC or CB, one or the same thing, multiply by the height part in this trapezium is AD or OC. So, I can write anything AD or OC, they are both the same, fine. Now, replacing the values, half multiply by this OA is actually represented as the initial velocity, plus this CB is equal to the final velocity, multiply by this AD is the time. Got it? Fine. So, now my equation becomes S or the distance is equal to u plus v upon t multiply by t. U plus v is in bracket. Fine. First of all, I will take this 2 and cross multiplying it, I will get 2s is equal to u plus v, and if I actually relate what I am exactly going to derive, I am going to derive the third equation of motion, which says that v square v square is equal to u square plus 2as. Now, in this equation we do not find t anywhere, right. So, this is basically a tip for us to relate that we have to remove this t from here. And how we are going to relate it? We have just studied that v is equal to u plus at, this is the first equation of motion, which can be represented as v minus u is equal to at, taking u on the other side. Now, once again taking a on the other side, I got t is equal to v minus u upon a, right. So, rather than writing this t, I can write v minus u upon a. Got it? Now, simply as I can relate 2s is equal to, now this is v plus u and v minus u. I know the formula a plus b into a minus b is equal to a square minus b square. This is a mathematical formula, we are aware of it, we should be, right. So, rather than writing u plus v and v minus u, I will just write, this is also expressed or related as a minus b, a plus b. So, this will be equal to a square minus b square. Now, the important thing is we are taking v as a, because here it is u plus v, a plus b, it may be u also, but when we are talking about v minus u, then as per the formula it is a minus b, a plus b. So, a is v, it should be taken as v square minus u square. This is important to relate, because if we take otherwise, there will be difference in the negative and positive sign. It may change our answer and may make it wrong. So, now v square minus u square is equal to 2s, and v square minus u square divided by a, cross multiplying 2as is equal to v square minus u square. Taking u square on the opposite side, I will get v square is equal to u square plus 2as. This is what exactly my third equation of motion was. Got it? So, these are the derivations of the three equations of motions graphically. They are quite important. Among these three, anyone may come to you and you will be just asked, what? Question will be, derive the third equation of motion graphically, or derive the second equation of motion graphically. For that, no graph, no values will be given to you whatsoever. So, first of all, you need to relate which graph you will be using to derive it, and for that you need to see that we are starting it taking some initial velocity. This is important. If you take the graph from here, you will not be able to derive it, not from the origin, right? Fine. You need to practice the graph and you need to practice this. Got it? So, this is all about graphical derivation of equations of motion. There are a few questions based on this, we will see. Provided first of all, you just learn and practice these graphical derivations. Thank you so much.